Welcome to the Open Network Foundation SDN proof of concept. Right now we're going to look at the microwave section. All right, so here's our topology section. Here you can see a network map with all the elements have been added, and the fact that they're all in blue here is indicating that they're all connected. So we have 13 vendors plus a Spirent as well. So the green connections here are our Spirent test center, which are generating our traffic. And we have our different services here. Today we're going to be, in this session, we're going to be concentrating on the microwave section, which is this one right here. And to do that, I'm just going to go up and show you the Ethernet services here. So here's a view of all our services, or Ethernet services, and the main ones we're going to be concentrating on in this session is this spur right here. So it's through 4 vendors of microwave. All right, so it's DragonWave, Intercom, Fujitsu, and Aviat in this section. And we were passing traffic throughout, and we will be manipulating and showing you how to control this using the open daylight. All right, so that is our physical topology. We're also going to look at, here's a table view of all the ports. So these are all the different ports that we're building our topology using these. So again, all 13 vendors are represented here with the different ports, both their physical Ethernet ports and the ports into their microwave sections or modems, for instance. And here are the various connections amongst those ports. So connecting the physical Ethernets to the modems, and you can see the relationships here. But all that is shown in the topology a lot more clearly and more versatility in there. All right, so also we are using the Spirent test center to generate traffic, and you can see that right here. So currently we are passing 250 meg of traffic. And let me grab it out of that. All right, and also we have our fault screen here. So this you can actually view from in here. So here's where any faults or alarms occurring in your network will appear, and this list can be filtered down to various vendors, so you don't need to see everything. So for our purposes right now, we're going to configure one of the devices, and I'll show you that section here. So in the configuration section, again, all the vendors are represented. You can see them here in your drop-down list. And you can pick whatever equipment you want and then manipulate it. So I'll show you some of these here. So for instance, we have okay, so for instance, you see Fujitsu and various statuses and configurations. If we have it. So you can see that it's polling and displaying the configurations from various vendors. All right, and we can try another vendor here. So let's go to Aviat. Okay, we see configurations here as well. All the various things are pulled. All right, let's try another one. Let's go to Elba. And look at their interface. We can see, again, statuses and configurations. It takes a moment just to populate the fields. So as you can see, you can pull various information, transmit frequencies, powers, statuses, can all be viewed. Okay. All right, so now we're going to select our first test here. So the first test we're going to do is we're going to log into one of our equipment vendors here, and we're going to disable the transmitter. And by doing so, we should see the alarms being correctly generated in the fault table. And also we should see our traffic be affected. So as you recall, the 4-vendor link that we're, the Ethernet service that we're using here. So this is the traffic is flowing through all 4 vendors. We should see that traffic stop. And then when we turn back on the transmitter, we should see the traffic continue again. So to do this, we're going to pick Intercom radio here. So that is the second microwave equipment in the chain. And under configuration here, we're going to open this. There we go. Sorry. All right. So as you can see here, we can manipulate certain functionalities. So we're going to disable the transmitter. And before I do that, I'm going to show you all the different windows here. So here we have our fault window, and I'm filtering it to intercom or INT for, we'll see only alarms that contain that. Here we can see our speeds, our traffic speeds on the Spirent Test Center. And on this one, I'm just going to submit the fact that I turned off that transmitter and apply it. All right, so there you can see we're getting relevant alarms for the intercom radio. So we have both the modem failure and the fact that its remote partner is down, and you can see that on both NEs. And you can also see over here on the Spirent Test Center that our traffic has stopped. All right, so now we're going to re-enable the transmitter. And apply that. And already our alarms are disappearing and our traffic is returning. All right, so now we're going to try another vendor, and we're going to try reducing the modulation. So using some path attenuation, we're going to fade the path out and let automatic or adaptive modulation reduce our modulation, and thereby reducing our traffic. All right, so for this one, we're going to pick Dragon Wave. I'll just choose Dragon Wave A here. All right. Now, I'm not going to be manipulating this throughout here. I'm actually going to be adding attenuation behind the scenes through the magic that is video. And as I do so, what we should expect here is that our transit power will start to, our data will start to decrease, and we should see alarms relevant to the adaptive modulation being no longer running on maximum. So I'll change the filter here to filter out to Dragon Wave. There we go. And now I'm going to apply some attenuation to the link. Okay. All right, I'm going to apply enough here that we get all the way down to 32 QAM. As you can see right away, we have the relevant alarms appearing in our fault table. And you can see that our traffic is now reduced to approximately 120 meg. Yeah, about 118 meg. So as I now decrease the attenuation, we should watch our traffic slowly start to increase as it climbs through the different modulations. And then I'll take out all the extra attenuation, and we should go back to where we were before. And our alarms should clear once we get to the highest modulation. There it is, and our alarms have gone, and our speed has returned to normal. All right, so some other things we want to show. So those are our 2 test cases for the microwave section, and we'd just like to show you a few of the other performance monitoring capabilities that can be pulled from the devices. So we can see things such as the performance monitoring history. Now, Open Daylight maintains a database of all these values. So to see current values, you would enter into the current section here for performance monitoring. That's within the last sort of 15-minute interval and last 24-hour interval. But once those have passed, the values, that data will be added to the database in Open Daylight and could be looked at historically. So here are some historical data. We're going to pick, let's see, another vendor here. Let's try Ceragon. All right, for instance, here's Ceragon. I'm going to look at the receive level historical data. And you can see here our minimum and maximum RSL historically over the 15-minute intervals. And you can see there's various options here. Transit power, modulation, signal noise is another interesting one where this data is useful. All right, so then also we can look at the links. All right, so in this one we're going to show you links from historical data using SIAE. And I'm going to pick my beginning and end network element. I'll show you the ODOA information. And then we can look at receive level. And here you can see it will keep both a table and a graph of the receive level from the historical data in the database.